Good morning. Today we are going to see a question paper problem that is on column axial load with uniaxial bending. So we can have this problem: design a uniaxial short column by limit state method. So M20 Fe 500 to carry a working load of 800 kilonewton, working moment 60 kilonewton per meter, bisecting depth. The unsupported length is given 4 meter. Column is fixed at both ends. Show detailed design calculation and reinforcement detail. So we have this problem was asked in July 2022-23. So given data, you can see we have given M25. So we have given data M25 FY 500 PU working is given. So 1.5 into 800, 1200 MU. M is working. So 1.5 into 60, 90 kilonewton meter. Now if you will go to IS 456 page number 90, so you can have effectively held in position and restrained against rotation in both ends. That means we have this both support fixed supports. And the recommended value we have 0.65 L. So if we will calculate 0.65 into 4000, then we will get it as 2600 millimeter. So knowing this value, we are in position to calculate minimum value, that is of width and depth of column, because L we have same along both direction, and this comes 216.67. So we will consider column 250 by 300 mm. As it is uniaxial, so we will not go for rectangular column. We will not go for square column, and we have provided it as a rectangular column with depth more than width, because moment is acting or bisecting the depth of the column. So then curve has to select from the following data. So we have steel on all faces, because that is given. Whatever is given, whatever charts are given in examination, you have to consider accordingly. So in examination, we have given steel on all faces. So we will assume D dash 50 millimeters. Generally, you can go D dash 50 always. So D dash upon D 50 upon 300. So we have 0.167. So we have to use chart available that is in question paper, that is D dash by D 0.15 and D dash by D 0.2. So you have to assume D dash and column dimension in such a fashion that your value should be between 0.15, 0.2. Charts are given likewise. If charts are given between 0.1 and 0.15, so your value should be between 0.1 and 0.5. Actually, charts will be given accordingly. Then we have PU upon FCK BD, and from this we will get value as 0.64. Then we have MU upon FCK BD square 0.16. Now see, we have to find value of P by FCK from 0.15. We have to find P by FCK 0.2, and then we have to interpolate this value for 0.167, and for that we have to interpolate it. So now we can see, so draw a vertical line from given value of MU upon FCK BD, horizontal from PU upon FCK BD, and intersection point gives us P by FCK. So we have to interpolate these values. Already I mentioned it for these values. Now you can see this is chart for FY 500. So what we have to see? We have to see FY 500. Then we have steel on all faces, and we have D dash by D 0.15. So now we have given value that is PU upon FCK BD 0.64 and 0.16. So from 0.16, you can see we have drawn vertical line. So we have this line, if you will see, 0.1, 0.11, 2, 3, 4, 5, 0.16. And that is from 0.64. So 0.6, 0.62 and 0.64. And where it will intersect, that will give us value of P by FCK. So you can see we have this as 0.02, 0.04, 0.06, 0.08, 0.1, 0.12, 0.14, 0.16, 0.18, and this will be 0.19 because we have this value 0.02 and 0.18 in between. So we will assume 0.19. So for 0.15, my value is 0.19. So keep in mind this value. Then we have this will be FY 500 again, steel on all faces, D dash by D 0.2. So these charts are given in IS code and in question paper, and I have taken from there. So now we have again 0.15 we have over here. This is 0.16. And then this is 0.62, 0.64 because this is 0.65. And intersection we will get it as, so you can have this 8.1246.8.2, and we have this value as 0.21. So for 0.2 we have 0.21, and now we will use this value. So you can see for 0.15, 0.19, and for 0.2, 0.121, and we will calculate this value, that is for 0.167, and we will get this value for 0.167, and that value will be 0.919 plus we have this value. And now if we will calculate this value, we will get it as 0.197. So we have this value as 0.197. And knowing this value of 0.197, we can find value of P by F. This is P by FCK. So value of P, percentage of steel, we can get it. And that is 0.197 into 25. So we will get this value as 4.93%. And then we have ASC 4.93 upon 100 into 250 into 300. And we will get this value, that is equal to 3697.5 mm square. And then we will provide 4 bars of 28 and 4 bars of 20 because we have to provide steel equally on all faces. And then from this we will get AST provided 3719.63 and required is 3697.5. So it is close. So if I will go 8 bars of 28, that will be larger one. If I will go 8 bars of 25, also greater one. So we have to go for combination of this. And by combination, we are in position to get value close to ASC required. So this is 3697.5. This is ASC required. And then from this, we are going to get lateral ties. So we have clause number 26.5.3.2. And then we have this value that is equal to 1/6 into largest diameter of longitudinal bar, or 6 mm, whichever is greater. And then largest we have 28 comes 4.61. So minimum we have to go for 6. So we will use 6 mm lateral ties, and pitch we have minimum of the 3. So we have this will be 250, which will be least lateral dimension. Then 16 into smallest diameter we have 20, so 320 and 300 mm. So we will provide 6 mm lateral ties at 250 mm center to center, and we will have diagram in this fashion. Now see, I have taken this value of column 250 by 300, and I got percentage of steel. If you will see, we have around 4.95. So generally we have to go for 0.826. So it's okay, but you can increase this dimension of column, and then you can go for again design. Then automatically you can reduce your percentage of steel. So I have taken this value 250 by 300. You can go 300 by 350. So that is your choice. Minimum values we have calculated, and then we can go for these values. So this is all about your column. That is axial load and uniaxial bending. So now we will stop here only. Thank you.